Hello everybody, and today we're going to be talking about polar coordinates. Now, before we delve deeper into this topic, I would just like to say, if you don't understand the unit circle, and if you don't understand radians, I would encourage you to check out my unit circle video, and the link is below in the description, because if you're trying to study this, it's best if you have a solid understanding of it. Otherwise, you're going to be wasting your time with this video. Now, with rectangular coordinates, we write it as x, y, where x is the distance left or right from the origin on the x-axis. Positive x's are this way, negative x's are that way. Y represents how far up or down the point is on that y plane. So if I were to write 3, 4, it would mean that it was 3 to the right and 4 up. Polar coordinates are different. Polar coordinates don't involve the xy plane. Instead, we have a radius r and an angle from the 0 degree mark on the unit circle. And so they're written as r theta, where r is the radius and theta is the angle it makes in relation to 0 degrees. So now what I want to do is I want to go through a series of examples just to get it ingrained in your mind. So feel free to pause the video if you want to practice or do anything that might help you study this better. But I'm just going to kind of go through plotting some different coordinates, and so feel free just to pause whenever you need to. Alright, so for 3 pi, I'm going to draw these axes here. And remember that with polar coordinates, it's radius, theta. So first what I need to do is I need to have a radius of 3. So if I had a circle going around, I go 3 out. Now, I need to make an angle of pi in relation to this 0 degree line right here. So I'm taking this and going all the way around to -3 over here to have a radius of 3 and an angle of pi. So right here, that point there is 3 pi. So now 4 pi over 4. Let's just make our axes here, and let's try the same thing again. Alright, so first you need a radius of 4, so you need to go 4 out. And now you need to create an angle, theta, that's pi over 4. So pi over 4 is right here, and so the point 4 pi over 4 is right there, and you can see here pi over 4. That's the angle formed there. And just to note, you don't draw a line out to each point. It's just to help you visualize, because this is the length, the length r. And right here you have r equals 4, and this is the length 3, where r equals 3. But this is just something to help you visualize what's going on. And if you were to make these points, like plot these points out, you would have something like, this would be 3 pi here. You wouldn't draw anything there. And for 4 pi over 4, you would have something like that, where it was just 4 pi over 4. You do not draw this line right here. So continuing on, we're going to make some more problems. So now what happens? What if you have a negative radius? What happens then? Because so far we've only dealt with positive radii. So these two problems are going to show how to do that. And if you already know how to do this and you're just using this as a review, feel free to pause the video. Alright, so I'm going to draw my axes. And so instead of moving positive 3 over, what you do is you go over -3, or 3 in the opposite direction. All right, so You move over 3. So here's your radius 3, but it's just in the opposite direction. So here's -3. All right? And then from there, you move it around the axis pi. So like that. And right here will be the point -3 pi. All right? So basically, the angle starts from wherever the radius is placed. So right here is pi. But if it was 3 pi over 4, for example, -3 pi over 4, sorry, negative, make sure it's negative, it would be right here. If it was -3 pi over 2, it would be right here. If it was -3 pi over 4, it would be right here. All right, so this is just, it's just the angle formed from where the initial radius is plotted. All right, so the same idea can be applied with -4 pi over 6. So first you got to go over 4, so -4, right? So you go over to the left and not to the right. So -4 over, and then from this line here, you go around the circle pi over 6. So you go over to this point, which is roughly, because pi over 6 is 30 degrees, and right there. And so now you're 4 away from the origin, and you're pi over 6 around the unit circle from the initial point it started. So this is -4 pi over 6. So to summarize, polar coordinates is r theta. If it's a positive r, you go over to the right. If it's a negative r, you start from the left. And then from there, you move theta from that given radius. So this would be like -r theta. All right? So that's kind of how you summarize polar coordinates. Now, what if they gave you a problem where you needed to convert polar to rectangular coordinates and vice versa? So polar to rectangular, rectangular to polar. All right? Now, the thing with polar coordinates, if you look at their construction, they are a radius r and an angle theta from the origin. Now, we know r, we know theta, and we know that this is a right triangle here, because if you were to draw a line, imaginary line, straight down to the bottom of straight down to the x-axis from this point, r theta, it forms a right triangle. Now, with right triangles, we have some special rules relating these x and y components. So to relate these components together, what we need to do is you just simply, to find the x component, you just take r times cosine of theta, and the y, you just take r sine of theta. So that takes you from polar to rectangular. So what if you want to go the other way? What if you're given xy? Well, to solve that, what we have to do is something slightly different. So we already know that r, because with right triangles, we already know the Pythagorean theorem. A squared plus b squared equals c squared. So we can also say that they're related. You can say x and y, take x and y and just plug them in. So x squared plus y squared equals r squared. And so r is equal to the square root of x squared plus y squared. Also, one piece of trigonometry that relates x and y to an angle is the tangent function. So to get theta, what you need to do is you need to take the inverse tangent and then y over x, right? Because we know that the tangent of theta equals y over x. So if you take both sides and by tangent, take the inverse tangent, you're left with right over there. So to summarize, to convert from polar to rectangular, you simply use r cosine theta for x and r sine theta for y. To take rectangular points and turn them into polar coordinates, we calculate r by using the Pythagorean theorem and theta by using some trig. So let's do some examples highlighting this. So let's just say we want to find in rectangular coordinates the coordinate 3 pi over 6. And so let's make, real quick, some axes. And so roughly about, let's say here, let's just say, all right, so this is 3 pi over 6. All right, and just to draw on the x and y components, this is the y component. Here's a 90-degree angle. Here's x. So now using what we already kind of showed in this video, x equals r cosine theta and y equals r sine of theta. So our r is 3. So x, so you put 3 in here. And then you put in cosine of pi over 6. And then same thing for y. Y equals 3 times sine of pi over 6. And now applying what we know from the unit circle, we can replace root 3 over 2 for cosine of pi over 6, and we can replace 1/2 for sine of pi over 6. And so our final coordinates are 3 root 3 over 2, and then 3 over 2. And so these are your x and y components that represent this polar coordinate that we have here. All right, so now we're going to convert these rectangular coordinates back into polar coordinates. All right, so first let's plot this out here. So it's 1 over in the x, and it's root 3 high. So this is right here. All right, so to find r, we know it's the square root of x squared plus y squared because of the Pythagorean theorem. So r is equivalent to square root of 1 squared plus the square root of 3 squared, which equals the square root of 4, which equals 2. So we know that the distance here is 2. Now, what about the angle? So the angle here is equal to, because tangent of theta is equal to y over x, we know that theta is equal to inverse tangent of y over x. So that's root 3 over 1. And so this theta here is equivalent to, and using the unit circle you can find this, pi over 3. And so that's how you find these, that's how you convert rectangular to polar coordinates. And so your final answer is 2 pi over 3. So hopefully that provides a good overview of polar coordinates and how they relate to rectangular coordinates. And if you have any questions, feel free to drop a comment below, and I will try to answer it to the best of my ability.